Hey everybody, welcome back to another AP Precalculus video.
Today we'll be going over FRQ Type 1.
Alright, so FRQ Type 1 is the first of the 4 different types of FRQ you will have to do on the AP exam. So we're going to be going over an example of this type of FRQ. Now, this basic information was covered in the FRQ Basics video, which will be in the description box below, and the 3 other types will also be in the description box below when they come out. Just a little refresher, FRQ1 focuses on units 1 and 2. It is calculator active, meaning you can use your calculator for this one, approved calculator that is. And then it focuses on analyzing functions that are represented through graphs and tables. It consists of 3 parts, and it'll ask questions about these concepts right here. So function composition, inverse functions, input-output values, zeros of a function, and behavior of a function, and then identifying an appropriate function type to construct a function model. And if that's really confusing, we're going to go in depth into an example today so you can see what we mean. Alright, so this is the example we are going to be going over again today in this video. So right here you can see that we are given a table of input and output values, and we're going to be evaluating this table that's given to us through these questions. So we're going to go over each part one by one.
So the first part of this FRQ is A1, and it gives us a composition function saying that h of x is equal to g of f of x, and we're asked to find the value of h of 3. So to do this, we need to know the basics about a composition of function. So if we have g of f of x, and we're trying to find h of 3, we need to plug in 3 into f of x. So then if we look at the table here, we can figure out that that's 10. And then now f of 3 is going to act as the input value of g of x. So we found that f of 3 is 10. So now we need to find g of 10. And we can plug this into the equation that they gave us. So 4.1 minus 2e to the 10 minus 6. Okay, that is supposed to be a 10. And then we can use our calculator to approximate this value. Okay, so now to approximate g of 10, we can use our calculator. And first you need to click Y. And you need to plug in g of x into y1. So 4.1 minus 2. And then click second, and then E to get E. So now after you plug in your function into y1, you click second quit to get back to the main screen. So now you have to click alpha trace, and then you can get y1, and then you just put in 10, close the parentheses, click enter, and then that should be your value. So if you guys want a formulated way to show all your work to assure that you get full points, you can say it like this, but you can also do negative 105.096 and also earn full points.
Our next part is part A2. So find the value of f inverse 30 or indicate that it is not defined. So quick review on inverse functions. In the inverse of a function, the inputs and outputs swap. So an example would be g of 3 equals 4. The inverse would then be g of 4 equals 3. So let's take a look at our chart. We're going to be looking at f inverse 30. So since 30 is our input for this inverse, we're going to be looking at output values that are 30. So if we see right here, our output is 30 when our input of our original function is 12, which means for the inverse, that will be our output. It's a little bit confusing to think about, but just think about the inputs and outputs swapping. From the table, we know f of x is 30. So when x equals 12, f inverse of 30 is 12. Again, to receive full credit, you want to show all your steps. In a way, this is showing your steps. This would help you receive full credit. AP graders are looking for your work and your steps, so you want to make sure you have all of that. So that's why having a statement like this is really important. All right, so now we're going to move on to part B1 of this FRQ. And part B1 says we want to find all the values of x as decimal approximations for which g of x equals 1, or indicate that there is no such value. So we're going to be following these steps right here. Our first step is we want to take our calculator and we want to set y of 1 as g of x. So we actually did that for the last part already. As you can see here, if we go to y equals, we have our g of x already in there. So next, if we go to y of 2, we want to set it as 1 because that's what we want our g of x to be equal to. So y2, we're going to set it as 1. And then we want to graph both of those functions and then find the point in which they intersect. So to graph both of these functions, you want to click graph and make sure your window is set appropriately because sometimes it's really zoomed in or zoomed out. If you click on window, this is the extent to which it'll show on the graph. So you want to make sure that it's all right. All right, so the point in which they intersect is the point where g of x is equal to 1, because this blue graph right here would be g of x. You know that from the colors. We have blue and red. So the intersection is where g of x is going to equal 1, since anywhere on this line has an output of 1. So to find the intersection, we want to click second trace, and then we want to find intersect. So you can use your arrows, or you can just click 5. All right, first curve, the calculator is asking for what your first curve is going to be. You click enter in the second curve. So we're choosing this blue curve and then this red curve, enter. And then guess, because sometimes there are multiple intersections. So for example, if there was another intersection here, you would go closer to this one to find this one, or closer to this one to find this one. Since there's only one intersection, it doesn't really matter, but I will go closer just to show. And then you want to click enter. And then the calculator will automatically tell you the ordered pair. So 6.43825549, and obviously the output's going to be 1. So this is the input value in which g of x is equal to 1. And again, it's really important that you have your statement right here. And this time we actually did truncate it to 3 spaces after the decimal. That's the farthest they're going to look. So again, your statement, your work is super important. You want to include this in your answer.
All right, so moving on to part B2, we are asked to determine the end behavior of g of x as x decreases without bound. And we have to make sure to use proper limit notation. So there's 2 ways to approach this problem, or 2 ways that I know of. And first I'll go over option 1, which is the way that worked best for me when I was taking pre-calc. And this is calculator based. And option 2, you can do it without a calculator. All right, so the first way to approach this problem is to enter the function g of x into your calculator. And from an earlier step, we have already done that, so it's right there. And now we can look at this graphically to find the end behavior. So if you click graph, you can see the graph, and you can zoom out a little bit by going to your window, just so you have a better view of the graph. I'm just going to do -30 to 30. So what I would do is I click second trace, and then I would go to intersect. And then I try to see what y value it approached. And here we can see that it approaches 4.1 as x decreases without bound. So this was just like a way, like a trick that I found helpful for me in a way that I did it. But there's also another way to do it. So the second way to approach this question is to understand that e to the negative exponent is going to be 1 over e to an exponent. And as x keeps on decreasing, the exponent's just going to get bigger and bigger, which creates a even bigger fraction. So it's going to be such a small decimal that it will essentially just be 0. So then that would just be 4.1 minus 0, and you would get 4.1. And so as x decreases without bound, g of x will get infinitely close to 4.1. And your answer to this question will be the limit as x approaches negative infinity of g of x is equal to 4.1. And to get full points, you want to make sure that you're writing out the statement as x decreases without bound, g of x will get infinitely close to 1, as well as including the actual limit notation. So if you guys are still confused about option 1, here's a graphical representation. And this is 2e to the x minus 6. So this was part of the original equation. And we can see that as x is decreasing without bound, we can see that g of x gets infinitely close to 0.
All right, so this is the last part of the FRQ type 1, part C. So C1 and C2 kind of go together, so we're just going to keep them together on the same slide. So we want to use the table of values of f of x to determine if f is best modeled by linear, quadratic, exponential, or logarithmic function. So this is going back to looking at the relationship between the inputs and the outputs of our given function. So we're going to be looking at this table right here. And we want to look at the relationship between how the inputs change and how the outputs change. So what do we notice here? Well, the outputs are increasing by 10 units as the inputs are doubling every time. So 3 multiplied by 2 is 6, 6 multiplied by 2 is 12, and so on. So knowing that, we can say that f of x is a logarithmic function because logarithmic functions have this relationship with their inputs and output values. So part 1 is asking for the function itself, which is logarithmic. And then part 2 is asking for a reasoning. So we want to explain the relationship that's going on here. Since inputs increase by a factor of 2, we would say that the inputs are changing proportionally. You're multiplying by 2 every time over equal length output value intervals because each output value is 10 units apart. So you want to have this statement right here. And that's really important. And then I think providing an example is really helpful for your explanation. So we talked about how over the output intervals, 10 to 20 and then 20 to 30, evenly spaced, so equal length output value intervals, inputs increase by a factor of 2. You're multiplying by 2 each time that happens. That example can showcase why f is best modeled by a logarithmic function. Again, explanations are super important, not for just this question, but all your FRQ questions, your work and your explanations. That changes how many points you receive. Can't stress it enough how important that is. Thank you guys so much for watching FRQ Type 1.
Stay tuned for more AP Pre-Calc and math content.
Bye!
Bye!